the design of our subsystems, as well as our finances and budgeting, testing before the competition, and the results of the competition. And at the end, we're going to take questions from you guys. For the design requirements, we were supposed to build an off-roading vehicle, which is durable and safe. Most of the safety requirements were outlined by the SAE Baja rules. We had other specifications we had to follow, such as, you can see, the maximum width of 64 inches and whatnot. We were also restricted by a 10 horsepower engine provided by Briggs & Stratton. Here, in the timeline, as you can see to the left over here, most of it was, we took a lot of time in the design process, and once the chassis rolled in the middle of February, other subsystems started to follow through, and at the end there, we finished the fabrication of our subsystems towards the end of May, which left us with about a week of testing before the competition. For the chassis design, the chassis was designed using CATIA, and the design was mainly to reduce weight, maintain the structural integrity when it comes to stiffness and strength, as well as make sure that we were not going to have any interferences once we start fabrication or assembly. The biggest issue that we ran into this year was to try and accommodate our new rear suspension. For the analysis, ANSYS was used for a different FEA. Some of the stuff what we did was try and get the torsional rigidity, make sure our chassis is stiff to allow our suspension to do its job. And we ended up with a torsional rigidity of 883 pound-force foot per degree. And we also studied other effects, make sure in case the car cartwheels, we're not going to have any broken members if we are subjected to adequate forces. For the fabrication, we had our CATIA files outsourced to a company called VR3, and they did our profiling and bending of the tubes, which helped us save a lot of time and a bit of material as well. As for the tabs to mount other subsystems, our tabs were laser cut for accuracy. Now Juan's going to talk about the suspension design.
So for the front suspension, we used CATIA to design it. We ended up using the same suspension points as last year as we found these to be desirable. However, we did redesign the upper control arm and we strengthened the lower control arm. Design of the upper control arm, we basically straightened the members to be able to better accommodate forces, lateral forces. And at the lower control arm, we thickened the tubes for impact. We also made the suspension adjustable. So we can change camber, caster, and toe angles. And in the steering, we have a fast ratio rack and pinion steering. For the analysis, we used Adams and CATIA. We used CATIA for kinematic analysis to design the actual arms. And with Adams, we used it to design the suspension points. We reduced bump steer, as you can see in the graph, over the 10 inches of travel. We only see about 0.4 degrees of change in toe, which is critical because we don't want to be bouncing and then turning. We also did a roll analysis that we were changing from a solid axle at the rear to an independent suspension. However, we found that the rear suspension that we already had enough roll stiffness that we could neglect this. And we also have round profile tires in the car, which allow us to neglect any camber changes. For the fabrication, we use same as the chassis. We use VR3 for the tubes. We also have to manufacture some parts. As you can see, the cup there for the ball joint that was done using blade here in shop. We also used quads for setup. We basically had one-to-one quads, and this was to make sure that the build part was as close as possible to the design part. We had some purchased components like the wheels, uprights, ball joints, and for the steering rack, we outsourced it. Rear suspension, we also use CATIA. This is a fully independent trailing arm suspension. We try to make it as simple as possible and as strong as possible. We incorporated an adjustable cam within the left arm, and this was done to be able to tension the chain. We also made it as strong as possible to withstand lateral forces, as this is the first time that this rear suspension is being put into a Baja car, and we didn't know how the forces, how the arms would react under lateral forces. So for the analysis, we used WinGeo and CATIA. WinGeo was used to determine the points of the suspension geometry, and CATIA was used for its FEA package. We did a side impact analysis and a rear impact analysis. For the side impact analysis, we assumed, or we put a 5G, 5Gs being with the weight of the vehicle, which is about 400 pounds. And with this, we made sure that the arms were strong enough to withstand any lateral forces. Fabrication is pretty much as the front suspension. The R3 for the tubes, we used the pause for setup, and the cam fabrication was done in-house as well, using the mill and lathe. And also we had some purchased components like the bearings and the hubs outside wheels. For the drivetrain, as was mentioned earlier, we have a 10 horsepower engine that every single vehicle uses. So we were forced to use that. However, we couldn't pick our transmission, so we decided to pick a 6-speed sequential transmission. To connect the two, we have a floating PTO shaft, and to transfer the power to the wheels, we have a chain and 2 inward CV joints. Fabrication, we had to fabricate a few components. These were the chain guard. We have a hollow mid axle which contains the male portions of the CV joints. Gun drill and heat treated stub axles, which contain the female versions of the CV joint. And we modified the transmission casing for accessibility. The CV joints came from Ford Focus.
For brake design, we made sure when we designed the brakes that we can access them easily in case we need to work on them later on. As well as we focus on a couple other things like have them adjustable if we need to have different drivers in the car. We also had a separate motor from the sprocket, which we ran differently from the last 2 years. We also had a deck pedal at the end based on the recommendation of our driver for comfort. As for the analysis, CATIA was used to try and produce lightweight pedals and rotors. As for the fabrication, the rotors were water jet cut at centerline, and the pedals were CNC machined. As for the mounts to mount the brakes to the chassis, they were also laser cut. As for the body and seat design, we also had some rules to conform to. The main issues that we had to deal with, other than that, were driver ergonomics. Obviously, we tried to have a seat which was as comfortable as possible, so we went with a hammock style seat, as we had success with it over the past few years. As for the body, we also added an opus form for driver comfort. As for the body, we used last year's body panels, which were vacuum formed TPO sheets, and we tried to fit them on our modified chassis. As for the analysis and fabrication, we actually did a full test on our seat to make sure that's the design that we want to go through, that we did not have to change it. As for the webbing of the seat, it was outsourced. It was done at Spartan's Sling, and the headrest was also embedded within the seat. You can also see that we used carabiners to attach the seat to the chassis, which allowed us to adjust the seat in height and width. The 2011 panels were used and fitted, and we were successful to do that, so that helped us reduce some costs and time. For the finances, budgeting is a big part of every project, as you know. And the typical cost, or the typical estimated cost of a Baja vehicle is just over $16,000. However, we were fortunate to use a lot of previous year's materials and components, as well as in-kind work. So that left us with trying to build a car with just under $9,000. If you see over here, our income from our donors was just over $9,000, which is good. And you can see over here in gold the engineering student fund, that component fund. That money, we are awarded that money, but we have not received it yet. So once we receive it, we would have built our car within budget. As for going to the competition, those were personal expenses that we managed to pull off through fundraising. As for testing, like I mentioned earlier in the timeline, we had 1 week of testing before the competition. and in that 1 week we were able to squeeze in 4 hours, which helped us to tune the vehicle, whether it was the suspension, the chain clanking, maneuverability, brake testing, and such. And Juan's going to talk about the competition.
So as you can see, these are all our results. I'm not going to go through all of them, but I would like to draw your attention to the maneuverability, suspension, traction, and endurance, as these are the main events. Maneuverability, we placed 38 out of 119 schools, suspension and traction 51st, and the endurance we placed 17. Just to put it into perspective, the endurance is the most important race, and it has about 40% of the total points for the whole competition. As you can see in the calls, we also had a 100-point penalty. This was due to some discrepancy and miscommunication, and we ended up handling something like this. Overall, we came in 35th out of 119 schools, and these are schools that come from all over the world, including the United States, Canada, Brazil, Mexico, Venezuela, and even as far as India. So we did encounter some issues during the endurance race. We ended up breaking a frame member. The reason why we broke this was the failure was due to twisting moments from the driver, and in combination with lateral forces from the suspension. We also had some minor breaks. The belly pan cracked due to some bead rolling that we did on it. We also had a CV boot tear, and we had some worn transmission dog ears, which caused the transmission to pop out of second gear. And this was a big issue because it did cost us a lot of time doing some of the maneuverability events. So, valuable experience. We learned a lot from this project. We had a lot of hands-on experience, as a lot of the car was built by us. We also learned, during the design stage, we learned a lot of software packages, like CATIA, Adams, ANSYS, WinGeo. Time management is obviously a big thing for all our projects, same with the communication and teamwork as we're working as a team, and budgeting. We also did a lot of networking because we had a lot of interaction with the industry, going to donors, asking for in-kind donations and such, and we got to see some of the industries that we will be working on. One thing that a lot of projects don't get to do is we got to benchmark our project with other schools. So this was great. At the competition, we came 35th, and we think we did well compared to a lot of other universities. So some improvements that we'd like to see done in the car for next year. Weight reduction, as any race car, the lighter, the better. We think we could reduce some weight in the chassis, suspension arms. We think we could reduce weight by changing some materials. Body panels could definitely be changed, and the bearing housing was a little bit overbuilt. We'd also like to see the inclusion of an anti-roll bar to increase roll stiffness in the vehicle, and adjustable shock mounts to increase the ride height for different events like the mud bog or the rock crawl. We also like to see a change in the wheelbase and track width to improve handling. And as you can see in this picture, this is the car after the endurance race, and there's a lot of mud on it, whatever, big deal. But as you see the car right now, it has an extra 100 pounds of mud on it. So if we could find a way to reduce, to maybe dump 30, 40 pounds of mud during the endurance race, like halfway through, it would give us a huge advantage over the other schools. We'd like to thank Dr. Bruce Meinecker, who was our advisor for this project. We had a lot of input from him. He actually was the one that came up with the idea for the independent rear suspension. Mr. Bruce Durfee, without him, this project would have never been able to be done. He helped us out a lot and put in a lot of long hours for us. Mike Duty, he's a GA for the capstone, and he was also our driver, and he also put in a lot of hard hours. And over at the S6 All Sensor Shop, we'd like to thank them because we did get some work done over there. Thank you very much. We'll take any questions that you may have at this time.